Today we are going to solve a problem from ninth class. This is from the lesson 1, the third problem. Okay. First we have to read the problem. A point of mass starts moving in a straight line. Let's try to guess. A point of mass moving in a straight line with a constant acceleration a at a time is t after the beginning of a motion. So the acceleration changes its sign without change in magnitude. So determine the time t naught from the beginning of the motion in which the point mass returns to the initial position. So we have to find out, we have to write what is given. So initial speed of it is u is equal to 0. Acceleration is a and time is t. So first we need to find out the distance. S is equal to ut plus half a t square. Okay, so according to this we have to substitute. U is nothing but 0 of t plus half a t square. So we'll get a value S is equal to half a t square. Okay, so this is the distance traveled by an object. Okay, now we want to find out the speed of it, I mean final velocity of it. Final velocity of it. So v is equal to u plus at. Okay, we know that already u is 0 plus at as usual. So finally the final velocity v is, this we are finding, v is equal to at. Now in equation what is given? The acceleration changes its sign. Okay, that is a is equal to minus a meter per second square, and displacement, that is s, is also changes, minus s. Okay, and time will take it as a t2 seconds, and initial, here this final becomes a initial of it. Okay, so that's why we'll write u is nothing but v is equal to at. Instead of u, we'll write the v value. Okay, right. So final velocity becomes a initial velocity. So according to this, if we write, that is u is equal to at. Okay, let's substitute all values. Again we have to use the formula. The distance, displacement, s is equal to ut plus half a t square. So s is nothing but minus s, that is half minus half a t square is equal to u. Here u is nothing but at. T is nothing but t2. Here the time for a second. Okay, t2 plus of half, nothing but acceleration changes, so that's why we write it as minus half a t square. So that's why minus half a t square is equal to a t2, here t2, plus into minus, minus half a t2 square. Okay, so what is common here? A is a common, right? We'll take the a. 1 by 2 t square is equal to a of t2 minus 1 by 2 t2 square. A get cancelled. T square by 2 is equal to, minus t square by 2 is equal to, LCM of it is 2t2 minus t2 square. Here 2 get cancelled. Then we'll get t square is equal to 2t t2 minus t2 square. Okay, now minus this will take this side, nothing but plus t2 square minus 2t2, this is minus t square is equal to 0. Now we have to find out the t2 value. Okay, so this is nothing but, when we compare this equation with the quadratic ax square plus bx plus c is equal to 0, to find the variable we have to use the formula x is equal to minus b plus or minus root of b square minus 4ac by 2a. Here minus b is minus of minus 2t, okay, plus and minus root of b is minus 2t whole square minus 4 into a is 1 and minus c is minus t square, nothing but t square, okay, by 2 into a is 1. Fine. Now this is 2t plus or minus root of 2 2s are 4, 4t square minus into minus plus 4t square by 2, okay. 2t plus or minus root of 4 4 8 plus t square, 8t square by 2. Here 2t plus or minus, we'll write it as a 4 2s are 8t square, right? This can be written as 2t plus or minus 2 root 2 t. Here t root get cancelled, so that's why we'll get here t by 2. What is common in these 2 is common, 2 of t plus or minus root 2t by 2. So t 2 and this 2 get cancelled. So what is left here? T plus or minus root 2t. This is the t2 value. Okay, the total time we have to find out. I'll do this here. Total time t is equal to, that is t naught is equal to t plus t2. T plus t2 is t plus or minus root 2t. 2t plus or minus root 2t. Therefore, t naught value is 2t plus or minus root 2t.